Good day guys, today I am going to guide you the step of Roboguide simulation of vision camera. First of all, open your Roboguide and click on the file icon at the menu bar, then click on new file. When the work cell creation wizard popped out, then make a new name for your work cell. Now click next button to continue to select robot creation method. Select the controller version and then click next. For this tutorial I am going to use 10/12 robot. Click next until robot option page. Search for the IR Vision, then select IR Vision 2D package and IR Vision 2DV. Now click next button until finish button, turn to clickable and then click finish button. Wait for the Roboguide to process your selection until the robot showed. For my preference, I would like to remove the grid line of the Roboguide world to make the view clean and tidy. So if you like to do so, please follow my step. After removing the grid, make a new floor for the robot world. Then looking for the obstacle title at the tree view, and then right-click on it. Select Add Obstacle and then Box at the side list. The size of the floor just need to be larger than the robot cell should be enough. Most of the time industry facility floor was painted in green epoxy. So I select the preset dark green as the floor color. Normally, robot does not directly mount it on the floor, so we must add on the base for the robot. At the tree view, expand the title name C:1 robot controller and then right-click on Add Dress Out, then select for base and then box. If you don't have the design of the robot base, put the box size slightly bigger than the robot base size. To make the base look more realistic, add on a link at the dress out. Now, adjust the robot height according to design base height. Now, add the additional link for the base. Expand the dress out title, then right-click at the base, dress out 1 and then select Add Link and then select Box. Resize the link box to bigger than the base box, and about 20 mm of height is enough. Please remember to change the color of the box. It's time to import the workpiece table. Right-click at the fixture at tree view and then select Add Fixture. If you have your own designed jig, you could import through single CAD file option, else you just need to select CAD library to add in Roboguide packaged fixture. I would like to select a table for this project. This table CAD origin does not attach to its base, so we need to measure its height to put on the ground correctly. Go to function bar and look for ruler icon and then left-click at it. When the measurement tool screen popped out, left-click over the tabletop surface and then left-click again at the bottom of the table leg. Then now you know the height of the table. Let's rotate the table to correct orientation using the triad. After that, key in the height from measurement. Adjust the table position to a reachable range of robot motion. You can drag the triad to move it or just key in the coordinates. Let's continue to add the camera stand. Again, add fixture using cylinder and set the size accordingly. Rotate the cylinder and move it using the triad to move nearer to the location that you required. Then apply round off to the coordinates value. adding the horizontal bar for the camera stand using box and set the size accordingly. Confirm the position of the fixture, then ready to lock down the position to avoid mistakenly move the fixture. Double-click on the 3D fixture to access the properties of the CAD and then check the box lock all location values. Repeat it for all of the CAD including robot. Remember to save your data frequently, although autosave is enabled to avoid unrecoverable software crash. After those preparation, it's time to go for Vision. Please look for the title named Vision at Tree View. Right-click at it, then select Enable Vision Simulation. Answer the popped-out window, OK. Wait for the virtual controller to restart, then your Vision is ready to connect. Adding camera CAD is required at this step. At Tree View, look for Sensor Unit title and then right-click, select Add Vision Sensor Unit and then Add 2D Camera, then CAD Library. The CAD library will pop out after that. Scroll down to find the camera name, Camera Package BWLED, then click OK. When you need to move the camera, do not click the CAD directly. Select the Sensor Unit 1 at Tree View, then move with the trade-or key in the coordinates. Rotate your camera according to fixture position, and then round off the position. Double-click on the camera body to open the camera properties and then select the View tab. Change the height of camera view zone at size setting to 900 mm. This setting does not affect to the view size. It is a simulation of camera shooting action. Go to Setting tab, select the focus length to 25 mm. This setting will change the camera viewing area. If you required wider zone to view, you need to reduce the value of focus length. In actual world, this represented to the camera lens focal distance. It's time to check our camera connection. Go to Vision tab. If the data of connected vision is empty, you are required to go to Vision title at Tree View, then double-click on it. At the General tab, go to Device drop-down list and select the Sensor Unit 1 Camera 1. Go back to Camera Properties and then Vision tab to verify the connection. Now the connection is up. Now, we need to add on the end effector for robot. Expand the Tree View title of GP1, ArcMate 100 ID, then expand again over the tooling title. Double-click the UT1 for the Properties window, then select the General tab and click the Robot Library icon. Select Pointer and click OK, then click Apply at the General tab. After that, go to U-Tool tab and check the Edit U-Tool box, then change the W value to 180. Robot current position is blocking the camera view, so required robot to move away. Click the Teach Pendant icon at function bar, then wait the Teach Pendant to boot up. Click the POSN button at the Teach Pendant and then modify the joint position as above. Then click Move to button. Calibration of camera is now proceeding. Calibration grid is required to place on the top of the table. We can add the calibration grid from the CAD library too. Right-click at Part over Tree View, then select Add Part, then CAD Library. There are 3 sizes of calibration grids available from CAD Library. The smallest is 7.5 mm, the medium is 15 mm, and the largest is 30 mm. Please select A05B, 1405, J912, which is the largest one. Let's add the part to our table. Open the properties of the table, then go to Part tab, then check the box of the part inside the list and then click Apply button. Check the Edit Part Offset box to enable position modification. Move the tray to adjust orientation of the part and then round off the coordinates value. Use Measurement tool again to find the thickness of the part. It is 12 mm. The position coordinate is refer to the origin of the table, so overwrite the Y value to 12 mm. Check the rotation to match robot world coordinates rotation. It's not necessary to do this step but just for better understanding. Move the calibration plane center to near the view center of the camera. Go to menu bar on the top of the Roboguide, go to View tab, then select Camera View to check the view of camera. Try to fit the 3 big dot at the center of the view. With actual calibration plane, it does show the dot-to-dot distance on the calibration plane but not available in Roboguide, so measure it to reconfirm again. To let the robot calculate the position of camera during calibration, position of calibration plane required to set up the user frame. Unfortunately, Roboguide is difficult to touch up the user frame, but there is another way to attach user frame directly on the calibration plane. At the tree view, open the user frame and select user frame 1. From the pop-out window, go to Attached Setting, drop down the list and then select the part added previously under the table with leg. After that, check the Edit U-Frame box to enable editing the position, then set the user frame data to all 0. Move on to the vision calibration, go to menu bar and select Robot and then select Internet Explorer from the list. Now, select IR Vision, Vision Setup. Select the Create button at the bottom to create camera data setup. Key in the camera name to create the camera data. After complete create the camera data, double-click at the data. Select the connected camera, then set the robot-mounted camera to No. Ignore the exposure setting and LED setting, because Roboguide World does not simulate lighting. Select Grid Calibration at Calibration. Click at Calibration Procedure icon. Ignore Robot to be offset because only one robot using. Ignore Application Frame to set because the calibration plane does not flip too much from the robot orientation origin. Grid spacing set to 30 mm. Ignore number of plane because fixed camera and robot not handle the calibration plane. Select No at Robot held Calibration Grid and then set Calibration Grid Frame at User Frame 1. For the projection remain perspective. Camera distance set to override focal distance. Then set the focal distance to 25 mm. If your calibration plane is in position, then proceed to click Set at Fixture Position Status. Click the first plane button, then bracketing the full circle dot as much as possible. Please remember to save your calibration data after complete calibration. Check the vision setup data. Does the standoff distance of camera to calibration plane in range? We are ready to create the vision process program. Here we go. Click the Create button on the bottom of the screen, and then select the 2D Single View Vision Process under Vision Process tool. Then key in the name for Vision Process and click OK. Back to the Vision Setup screen, double-click on the Vision Process tool that you have created to enter the edit mode. Now, select the 2D Single View Process at the top right of the screen. Then back to the setting list at below. Set the camera with the calibration camera name. Set the number to find to 1. Set the offset mode to fixed frame offset. Set the offset frame same as your calibration user frame. Remain the sort key, short order, delete duplicates, measurement in default settings. Image logging mode set to do not log. Display image remain default. Ignore the setting below, then we move on to the Snap Tool 1. For this tool, all setting remain default is okay, but if actual world adjustments are needed to improve the image quality. Now, we move on to the GPM Locator Tool 1. This tool is recording reference image tool and also apply condition judgment on future captured image. Go to setting list below, click on the Teach button and then the teaching bracket screen will appear. Then now bracketing the image you want to reference, then click OK at the bottom. Ignore the G-edit, this image does not require to edit the graphic. Move on to Set Origin button and click it. Move the cross mark to the position as the reference origin of your image, and then click OK at the bottom. If you notice that there are some unwanted image captured together and cannot be excluded from the bracketing tool, you just need to mask it as well. From the image, that two small circles are not the main item for vision to find, so, we apply mask with the training mask column and click Edit. Now mask those two small circles and then click OK at the bottom. Don't forget to save your vision process tool setup after you done the masking. Then click Snap plus Fine button at the bottom of the screen. Vision process tool seems like found to match condition items from the image, therefore we have to make adjustment the score threshold to reduce the mistake in judgment. After the adjustment of the score threshold, the result becomes stable. Now, we can proceed to next step. Move back to the parent setting page of 2D single view vision process. Then scroll the setting list to the bottom and find reference data. Reference data to use remain unchanged, due to no other image to find in same vision process. Part Z height no need to set in case robot is touching the calibration plane. If the actual workpieces are higher than the calibration plane surface, then measure the height and then input to this box. Now click the Snap plus Fine button at the bottom. Once image show found success with green bracket, then click Set button at reference position status. Don't forget to save again after complete setting. Following with End Edit button on the right, you can close the Internet Explorer now as in the vision process tool is ready to run. Now, turn on the Teach pendant in the Roboguide. We are ready to create motion program. Click the Select button on the Teach pendant, and then click the Create button on the Teach pendant screen. On the screen pop-out list, click at the Options or Keyboard selection, then name your program with the ASCII input keyboard. After key in the program name, press Enter twice to complete the creation. Please input the program according to the video. Enjoy some music while doing this. Declare tool frame and user frame at the beginning of the program is really important to avoid mistaken operation of manual choosing difference tool number. Before touch up a position in the program, please hold Shift and click on Coordinates button to check current active user tool number and user frame number. Click Previous button to exit the yellow pop-out screen. You can move the robot tool center point to the plane center directly through Set All 0 at the current position that refer to current active user frame. using tool offset method to reduce the touch-up point, but please make sure your offset data match to the tool frame orientation.
Take it real soon. You know we got what you need, baby. So take it, move along. I said we got what you need, honey. Come and groove along. Come on. Rolling on the highway, you know. Wow. Come on.
Now, add the vision instruction to call for snap and then wait for a tiny time, then get data from the vision system. Prepare a error branch for program to exit when vision fail to find the image. Apply the offset value from the vision register to the motion instruction. Find the step button and click it, then click the shift then click forward button to run the program line by line, until robot move to the position. Have a try on changing the position of the workpiece through the Table Properties Part tab. Slightly off the data and then run a program with Teach Pendant. Have a try on changing the position of the workpiece through the Table Properties Part tab. Slightly off the data and then run a program with Teach Pendant. Hey guys, tutorial is going to end now. Thanks for watching and try it out to master it.